All right, let's take a look at this problem. At first glance, you're saying, well, this isn't any different. I have a fraction. The fraction has an x in the bottom. You know, we've said 2 up to this point. If there's an x in the denominator of any fraction, let's make all of these fractions. It might make the end result a little bit easier to understand. It might not. If this confuses you, don't do it. It doesn't matter, really. It's just there as a helpful hint, I think. So if you look at this, you say, well, that fraction has a denominator of x. And since it's the only fraction, I'm going to multiply by x. So everything here and here is going to get multiplied by x. When I multiply this by x, I get x squared. When I multiply this by x, the x's cancel, right? That denominator will cancel with this, and I'll be left with just plus 5. And on the right, I have 6x. So what's this? Why is this different? Yeah.
You don't carry the negative in front of it.
Oh, sorry. Negative 6x. My fault. Thank you. But what makes this problem different from all the other ones we've done so far? We've seen x squared before, but in this problem, I had one on either side, so they canceled. In this problem, that's not true. So this is a quadratic equation. So let's go through again. Why do you think I record these questions? Because they include lots of stuff that you need to know, right? This is a quadratic equation. Quadratic equations must be set equal to 0. We have solved quadratic equations. We did it last week. All right? We have to set them equal to 0. I'll do that by adding 6x over to this side. From here, you have 2 choices. Well, you have more than 2, but I'm only giving you 2 for right now. You can, what's the F word?
Function, fact.
Not function, factor. Foil is when we have 2 binomials, right? We don't have 2 binomials, we have a quadratic trinomial. Do you know how to factor a quadratic trinomial? I sure hope so at this point. You can factor this down. So set equal to 0, factor, surprise, surprise, factoring becoming a common theme in a lot of these questions, isn't it? Okay? So if we can factor this down on the left-hand side, we'd have x in the front of both binomials. 2 numbers that add to be 5, excuse me, multiply to be 5 and add to be 6. Those 2 numbers would be 5 and 1. Now, if the product of these 2 binomials is 0, that means that x plus 5 could equal 0, or it means that x plus 1 could equal 0. Let's talk about this for a second. I don't know how much of this has occurred in the past. Okay, I don't think much, so let's discuss. I was able to factor this into these 2 binomials, and their product is 0. So if 2, and I'm going to use a very mathematical term here, you may want to write this down. If 2 things, you get that? Things, that's the very expensive term. That's why I went to college, so I could learn these really fancy words. I was being sarcastic. You don't need to write the word things now, okay? But what I'm telling you is, if 2 things multiply to be 0, finish that statement. If 2 values have a product of 0, what could you tell me? What conclusion can you draw from that? One of the numbers has to be 0. Thank you. One of those is 0. Does it matter which one? No. But one of them has to be 0. So when I factor a quadratic and I get this times this equals 0, then this factor could equal 0, or this factor could equal 0. And then I get two much smaller, simpler equations that I can solve for x, saying, well, subtract 5 from both sides here, we get x equals negative 5. Subtract 1 from both sides over here, x could equal negative 1. And that's okay. It's okay to get two answers as long as they work in the original problem. So I got negative 5 and I got negative 1. Do either of those answers make this equal to 0? The denominator. Well, if I plug negative 5 down here, will it be 0? No, it'll be negative 5. If I plug negative 1 down here, will it be 0? No, it'll be negative 1. So my answers are negative 5 and negative 1. Okay, so just to reiterate, multiply by the common denominator. If you recognize that it's quadratic, move everything to one side so that it's equal to 0, factor, and then solve those separate equations.